By now we've gone over several ways to solve quadratic equations. The first way we talked about was by factoring. Factoring, which only works if the expression is factorable. SADMEP, which works the best only if b equals 0. Graphing, which only really works if you want an estimation or if you want to spend a very long time plugging in x values and finding y values. Completing the square, which we just went over. And today we're going to be talking about the quadratic formula. The quadratic formula is a very simple equation, which works in every case for finding the solutions of a quadratic equation. Remembering that a quadratic equation is an equation which takes the form ax squared plus bx plus c equals 0, where a, b, and c are all numbers. When we're solving using the quadratic equation, the first thing we have to do is SADMEP everything to one side. So in this case, if 2x is being added on this side, I can move it over by subtracting it on both sides like this. The next step is to take the coefficients, so 3, -2, and +7, and then we plug them into the quadratic equation. So the quadratic equation states that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. As long as a does not equal 0, because if we try to divide by 0, that doesn't make any sense. All the numbers fall into a terrifying fiery hole of being undefined. This is a formula you're going to want to memorize. So using this formula, I simply am going to say, okay, x equals -b. In this case, b is -2. So -2 plus or minus the square root of b squared, so -2 squared, minus 4 times a times c all over 2 times a. So I'm going to see that because this is plus or minus, I'm going to just make it into two separate fractions. I'm going to have +2 over 6 plus or minus the square root of 4, so 4 minus 84, which is -80 all over 6. Taking that one step further, we can actually go ahead and reduce. 2 and 6 have common factors, so I'm going to go ahead and say 1 over 3 plus or minus the square root of -80 over 6. Right now you may notice that it's impossible to take the square root of 80. We're not going to talk about imaginary numbers yet, so in this case if we get this, we'll just leave it, and for now you can just say no solution, because that's not possible. Here's another example. I have x squared minus 5x equals 14. Well, in this case, I need to make sure, following the first step, that I move everything to the same side via SADMEP. Then, remembering our formula, that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a, I'm going to take the coefficients from this equation and plug them into the quadratic formula. So looking at this right away, I see that x squared has a secret coefficient of 1, so I'll just plug that in there so you can see it. Alright, we're going to get that x is equal to -5 plus or minus -5 squared minus 4 times 1 times -14 all over 2 times 1, which we don't have to write. Simplifying that, I'm going to split it into two chunks, and I'm going to get +5 over 2 plus or minus the square root of 25 plus, because there's a negative multiplying a negative, 56 all over 2. So I'll get the square root of 81 over 2. When I simplify this, and I'm going to do that in this little box over here, 5 over 2 plus or minus 9 over 2, which if I want to split that into two pieces, so I'll get 14 over 2, or I'll get -4 over 2. So I'll get x is equal to 7 and -2, because I went ahead and I simplified by dividing the top by the bottom because I have common factors. So what this actually means is that this parabola, if we were to graph it, crosses the x-axis at the point 7 and -2. And in this case you see that I was able to take the square root because it's a positive number, also because it's a perfect square. If it wasn't a perfect square, I could have just left it in this format and it would have been fine.